All right, so we're back for another lab. This is lab 7.5, which deals with EMF in series and parallel. EMF is short, of course, for electromotive force, and that's because batteries, with their voltage, they provide a force that forces the flow of electrons. So if we do this lab in class, we're going to be using some D-cell batteries, which are 1.5 volt batteries, and a digital multimeter. Now, a multimeter is probably one of the best life lessons I learned from taking physics. It's the electrician's number one tool, and it allows you to analyze wiring, outlets, whatever you need to, while you're kind of taking a look at problems. If you have any problems in your house for circuits and electricity and whatever. So it's a really important tool to learn how to use, so you don't have to call an electrician over to your house just because you have an outlet that's not working. We're going to use some wires and a light bulb. Now, since we're doing this lab digitally, we're going to go ahead and use the simulation again. And we can just go ahead and click on the intro portion, and that'll have enough tools for us to do this. So let's go ahead and jump to lab 7.5. And again, the materials are two 1.5 volt batteries. We'll talk about what exactly is going to happen. We can skip the instructions about the multimeter. In the circuit construction kit, we're going to be using the voltmeter. And the voltmeter provides us a way of measuring voltage. So we're going to start by getting a battery out. So it says we got terminals of the battery. So let's go ahead and grab a battery, and we're just going to set our voltage, the probe for the voltmeter, across each end of the battery, and you can see I get 9 volts. So it says 1.5 up here. Well, these are a 9 volt battery, and if I go ahead and click on the battery, it says right here 9 volts. So I could adjust it. I'm not going to worry about that. We're going to just go ahead with this. So what's the reading on the multimeter? It's 9 volts. What's the reading on the battery? It's 9 volts. Now we're going to hook it up with a light bulb. So let's go ahead and do that. Here's my battery. Here's my light bulb. And let's grab a couple wires. There's one. There's another. And I have a complete circuit, so the light bulb does in fact light up. Now, before in the last video, I kind of got into this, but in the upper right-hand corner, I have to show the current, either electrons or conventional. So the conventional current goes from positive to negative, right? But electrons, we know, actually flow from the negative terminal and go back to the positive. So there's the convention of how electric works, and then there's the actual flow of electrons, which is actually happening. So the question is the light bulb bright or dim? And in this case, it's kind of hard to tell because there is light coming off of it, but we'll see in a later step that is actually a dim light bulb. So now we're going to connect two batteries in series. So let's go ahead and let's break this connection off and grab a second battery and hook it in series. And you can see that they have the same orientation, so that it goes from positive to negative to positive to negative. And now when I hook up my voltmeter, I get 18 volts. I don't get 9 volts anymore. I get 18 volts. And this makes sense because I have two batteries, 9 volts. The other one is 9 volts. So they add together and they make 18 volts. Both batteries, 18 volts. What happens when they're placed in series? Those voltages are going to add together. And now we're going to go ahead and hook up our light bulb again. One, and we're going to hook up the other one. Now, thinking before it was dim with 9 volts, what's going to happen when I connect 18 volts? Well, that should be hopefully pretty obvious. We're going to have a much brighter light bulb. And we can also see that it's a much faster flow of electrons, right? The electrons are moving faster than they were before with only one battery. And that gets us into the concept of current, which we've also been talking about, and we will continue to talk about a little bit more. So the big part that gets a little confusing with this video is hooking up batteries in parallel. And that's why I'm really here to kind of help out a little bit. So let's go ahead and disconnect this. So we had one battery, we had two batteries in series. Now we want two batteries in parallel. And the way that I'm going to do this to make sure that the simulation does what I want it to do is I'm just going to go ahead and use a couple extra wires to do this. And you'll see why in just a minute. So I have two batteries hooked up in parallel. Now, if I do this wrong, if I hook this one up backwards, they burst into flames. And the reason they do that is because I have a short circuit now, and it's causing an infinite current. So you can also see animation speed limit reached, simulation reduced, because it can't keep up with it. It's a short circuit. So there's my circuit, and you can see that there aren't really any flow of electrons. And if I put my voltmeter across this, I can see though it is 9 volts. So I have two batteries hooked up, but my voltage is only 9 volts. And if I go ahead and complete this circuit, we can see, oh, my light bulb got way out of screen, that the light bulb is dim and the electrons are slower, just like it was when I had only one battery. And I can verify this by putting my terminals across the light bulb as well. And I can see there as well that it's 9 volts. Okay, so what's the voltage readings? I got 9 volts when they're placed in parallel. The voltage doesn't add or subtract, it stayed the same. And I placed the light bulb. Again, I have a dim light bulb. So you might ask yourself the question, why would things ever get hooked up in parallel? Well, the reason it is it helps with the overall current, right? If as I see this, I got two current sources coming together and pushing out the electrons. So in real life, batteries are often put in parallel to help with the current of the the current of the circuit, and not just the brightness and how fast it can put out the electrons. So that's two batteries in parallel, and that is it for Lab 7.5 EMFs in series and parallel.